tech reviews have taken us to some fascinating places: smartphones that fold, AR glasses that map the world in real time, drones that can fly themselves. But today, we're venturing into one of the most transformative and humanity-centric pieces of technology yet. Meet the PSYONIC Ability Hand, a bionic marvel that's less about convenience and more about empowerment, autonomy, and life-changing restoration. Yes, you read that right. We're reviewing a robotic hand. But not just any robotic hand. This is a carbon fiber, waterproof, motorized, sensor-integrated, and Bluetooth-enabled prosthetic hand. And it's not designed to play games or run apps. It's designed to give people back something they've lost: control, dexterity, and a sense of self. What exactly is the PSYONIC Ability Hand? The Ability Hand isn't science fiction. It's real, tested, and in the hands of users across the globe. At its core, it's a motorized prosthetic limb developed by PSYONIC, a company that's taking a radical new approach to assistive tech. It's constructed from lightweight carbon fiber and reinforced with durable metals, making it both strong and agile. Think of it as the mechanical equivalent of your hand, but engineered to withstand more and break less. But this isn't a clunky Terminator-style apparatus. It's sleek, refined, and optimized for real-world use. And here's the kicker: it's affordable enough to be fully covered by Medicare in the United States, which is a massive win for accessibility. From animal prosthetics to advanced robotics. To give some context, not long ago, I reviewed 3D Pets, a company that builds prosthetic limbs for animals using 3D printing. The simplicity of those solutions made them beautiful, just basic forms that dramatically improved quality of life. But the Ability Hand? This is the exact opposite end of that technological spectrum. Where 3D Pets focused on simplicity, PSYONIC embraced complexity in service of precision and control. Every nut, bolt, sensor, and wire in this hand has a mission: to mimic human hand movement as faithfully as possible. But how do you review a bionic hand if you still have both hands? Great question, and it's one that PSYONIC thought about, too. To test the Ability Hand, there are two methods available. One that's more traditional, and one that offers a glimpse into the future of human-machine interaction. The first method is via a wired controller, which simulates the motor function that would be driven by a real user's body. The second method is far more cutting-edge: EMG, electromyography. Let's start with the basics. Control Mode 1. The wired remote. The wired remote looks like something you'd expect to find in a lab: simple, sturdy, and functional. The hand locks into a socket on the controller, and a battery powers the motors and buttons. Once the system boots up, the hand springs to life, literally. It does a small calibration dance, a quick wiggle of the fingers, a subtle hum of servos, and just like that, it's ready. From here, the hand connects instantly to a smartphone app via Bluetooth. And when I say instantly, I mean faster than any Bluetooth device I've ever tested, even faster than most earbuds. Once paired, you gain access to a wide range of predefined grips. These include cylinder grip, perfect for holding cylindrical objects like water bottles or handlebars. Pinch grip, ideal for delicate items like coins, pens, or berries. Handshake, self-explanatory but surprisingly intuitive. Sleeve grip, designed to help users insert the hand into clothing without catching on fabric. Peace sign, hang loose and rude, more playful but still functional in the right context. Each grip mimics real human hand movements with astonishing fluidity, and you can cycle through them or trigger specific ones based on your needs, all from the app. Control Mode 2. Muscle controlled via EMG sensors. Now this is where things get sci-fi. The second, more advanced control method uses EMG sensors that read the electrical signals from your muscles. This is the same type of technology Meta is using in their prototype neural interfaces, where a wristband translates nerve impulses into digital commands. To simulate this for the review, I used a demo prosthetic large enough for me to insert my own hand. Then, I attached two EMG sensors to my forearm, strategically placed to pick up the strongest signals. Once in place, the system begins analyzing the difference in electrical activity between the two muscle groups. That differential controls the opening and closing of the hand. A specific muscle flex sends a signal to close the grip, while another opens it. With practice, it's possible to control the speed of grip movement, cycle between grip modes, trigger specific gestures. This is, without exaggeration, the closest a non-amputee can get to brain-controlled limb movement. Haptic feedback, touch, reimagined. But what's a hand without the ability to feel? The ability hand doesn't just grip objects. It provides haptic feedback that mimics a real sense of touch. There's a small vibration motor embedded in the unit. When pressure is applied, like grabbing a water bottle, you get a subtle buzz in return. This feedback loop is critical. It allows users to know when they've made contact with an object, gauge grip pressure, adjust motion dynamically. It's the difference between grabbing and crushing a grape, or threading a needle versus flinging it across the room. Putting the ability hand to the test. To see what the ability hand is capable of, I walked through several real-world tasks, ranking their difficulty along the way. 1. Picking up a water bottle. The most basic function, just grab and lift. Using the cylinder grip, I picked up a water bottle with ease. The haptic feedback gave me the green light that I had a secure grip. Difficulty, 2 out of 10. 2. Grabbing small objects. Switching to the pinch grip, I try to pick up smaller items like keys and coins. Precision is harder here, especially for a new user, but still possible. Difficulty, 8 out of 10. 3. Peeling a banana. This felt like a puzzle. It required just the right grip strength and wrist orientation. But with patience, I managed it. Difficulty, 5 out of 10. 4. Typing on a keyboard. Using the pointer grip, I was able to hunt and peck effectively. Surprisingly, the hand is compatible with capacitive touchscreens, meaning smartphones and tablets also work flawlessly. Difficulty, 1/10. 5. Writing with a pen. Here, I really had to finesse the muscle input. The grip needed to be just right to hold the pen steady. With effort, I scrawled a short note. It wasn't elegant, but it was legible. Difficulty, 7 out of 10. Final thoughts. Technology at its best. If you've ever wondered what good tech looks like, this is it. Not because it's flashy, not because it's trendy, but because it serves a meaningful purpose. So shout out to the brilliant team at PSYONIC for letting me explore the future, one robotic grip at a time. I'm handing the device back now, so it can go to someone who will truly benefit from it. In a world where software dominates the headlines, it's refreshing to see a piece of hardware that reminds us what innovation is really about: people. Until next time, stay curious, stay human, and remember, the future is already here. We're just catching up. Peace.